All right, our next speaker then today is Drew Galloway at TDA Research, speaking to on-body power module for first responders. Drew?
Thanks, Chris. Yeah, thanks for your time today. I'd like to talk with you about on-body power module solutions for first responders. I'd like to skip forward here to slide 5 just so we can look at the DHS's plan. So there is something called the Next Generation First Responder Smart Hub architecture, and the on-body power module is one component of that. The other components are communications module, sensors, I/O, and finally a control module, which most of us would consider to be their cell phone at this point. We're all used to doing I/O with cell phones. So TDA Research is addressing the power side of this. So why do we need an on-body power module? Well, I think most of us are carrying many electronic devices at this point, and we're all having to maintain them ourselves. So we're watching our cell phone batteries, our land mobile radio batteries. We're doing that independently of each other. It'd be nice to have a system that just handled that for us, so we didn't have to worry about it. The picture you see on this slide shows the power module on my shoulder strap there, but if you had a vest and that you were using every day, you would just hide this power module in the back of everything, so you still had access to all of those the loops for gear carrying. The only thing that would be exposed would be your device pouches that would be wired, and then the battery packs, so you could hot swap those. So who might use an on-body power module right now? We feel that anybody who's using a vest or could use a utility vest could rig up all their electronic devices and the battery packs and the on-body power module, and then they just have one vest to put on in the morning or at the start of a shift, and they would know that all of their devices were charged and ready to go, and they would have increased capacity because the two battery packs that the on-body power module uses to charge other devices have 74 watt hours of capacity. So it's significant improvement over any single device. We see in the little oval here that SWAT guys are carrying 1.5 pounds of spare batteries just to make sure that they always have a battery for a device if it goes down. And this solution would get rid of that. So it would be a smaller space and a little bit less weight than those spare batteries that the SWAT guys are already carrying. So we're thinking about everyone from police, SWAT members, EMS, rangers, anybody who's basically in the field could take advantage of this solution. So how are we handling our electronic devices currently? Well, right now, most of us are carrying spare batteries, maybe even a power brick to handle the phone. And we're monitoring the batteries of each one of these devices individually, and we don't have any personal area networking. So it's very hard to integrate all the information that's coming into us and post it straight to our cell phone or control module. And if we have a battery go down, we may have no recourse for bringing that critical piece of equipment back up. And then at the end of the shift, you have to take care of each one of these devices individually. So if you were to implement an on-body power module, then at the end of the shift, you just unzip your vest, you'd plug in one USB-C cord to a wall charger, and it would charge up the system's battery packs and all your peripheral devices at the same time. You'd no longer have to monitor any of your battery levels. All of your legacy devices could be handled. And you would be in a network situation which is in line with the DHS's view of increasing situational awareness by taking all available information and then putting it in a palatable display to the user so that they know where the team members are, they know what incident commander directions are going to be, and we just have a more coordinated system. So right now, we all have individual chargers for our devices, And in our vehicles, those are taking up a lot of space. The whole center console that you see in the car here, that could go away if you had a control module and a power module on your person. You'd get back a lot of space, and there'd be just a lot less maintenance and expense involved in the system. So what were the DHS's requirements? Well, we want the power module to be cheap. Batteries should be cheap. This is essentially a smart USB hub. So the whole thing should be inexpensive for organizations to buy. We want to make it easier to see what the battery status is. So there'll be visual indicators on the battery packs. And then if a battery pack ever gets low, you just replace the low one with a new one. So we call that hot swappability. The power module itself, which is this unit here, those housings are going to be IP68 or intrinsically safe, depending on your need. But the unit is essentially just a circuit board in a housing, and then we programmed it to handle all the charging needs of the devices that we've identified. So just a little bit more about our solution right now. We've got connections for 4 USB-C wired devices. 2 of those connections can output 60 watts and 2 can output 45 watts, which significantly more than most devices need right now, but we're looking forward. We also have Wi-Fi and Bluetooth communication capability. So if you have a cell phone that you're using as your control module, the information from all your devices and your battery packs will be sent to that phone. You just open an app and you can configure things or check on them on your phone. Right now, our battery pack of choice is a lithium-ion battery pack that's used by soldier modernization programs. We're buying the Bren-Tronics one specifically, but the system is future-proof. If a better battery solution comes out, the on-body power module either bucks or boosts those voltages down to what we need and then sends them back out to the USB-C devices. So while we're using lithium-ion right now, if a better one comes out, we can switch. So some more features. We're a little bit less than 30 cubic inches, which is small. It's like a couple VHS tapes. Supply voltages right now are 5 to 20 volts, but the new USB power delivery regulations allow up to 48 volts. So we could provide a much larger unit if you needed one for a squad or even something on the counter in your control area. Like I mentioned before, you can recharge the battery packs and all of your peripheral devices through one USB-C port, as long as that port's providing enough power. And the battery packs are smart batteries, so they monitor the number of times they've been discharged, and they let you know when they're getting close to the end of their lives, so you don't ever go out on patrol or on for a shift and have a battery pack just fail on you. You'll get some warning ahead. So this system, it eliminates the need to carry any spare batteries. It's low cost, and we think in the future you're going to need to integrate information coming in from 4 or 5 different devices, and it does all the networking for that. So it kind of is helping out the comms module of the smart hub architecture. So what systems are out there that we can compare ourselves to? Well, all of the special forces are using systems like this. The difference between our system and theirs is that all of their cabling is proprietary, and they're really meant to use just one large battery, usually the conformal battery. So that's not a hot swappable situation. All of their units must have their own battery packs, so when you unplug the system battery, they don't just go down. So that's an improvement. And in our system, you get to just use USB-C cords, which are available anywhere. You don't need the proprietary cabling. Our system's also cheaper than the one from Black Diamond or anybody else that's offering them for military use only. And then it's available to anyone, to civilians, to first responders. So the availability is a huge upside to this product. So where are we in terms of the development? We have a working circuit board. The form factor right now is, as you see here in the black model, that is a 3D printed case, but once we get through the first few voice of customer meetings, we'll make those changes if we get feedback from users, and then these cases will eventually be glass-filled nylon injection molded. So very tough and pretty cheap. We hope to do a demonstration at JAMX 22 out at the White Sands Missile Range at the end of April. So we'll have first responders charging phones or laptops with our units, and we'll see how they like them. I've said that we'll be ready for manufacturing in July of 2023. That's just when the project ends. We may be ready sooner than that. So a little overview of TDA Research. We've been in business since 1987. We're now up to 105 employees, and those employees are housed in about 75,000 square feet of lab and office space in the Golden area. We're primarily working on materials or device development, and that work has led us to work with the FDA, EPA, OSHA, NIOSH, NFPA, and others to try to get the proper certifications for our devices. So we're very familiar with the regulatory side of device development. So some things that we make and sell. One is the on-body oxygen generator for Navy F-18s. And we also sell what's called Super Soap DX12. And the Air Force uses that for aircraft washing and decon. So those are some of our commercial products. We've been developing technologies for first responders for quite a while. Right now, we're currently working on developing a wildland firefighter respirator. In the past, we've developed filters for overhaul operations. That's after the fire's out and you're going in and looking for smoldering spots. We're currently developing fluorine-free firefighting foams, and we did develop a temperature sensor for firefighters to warn them before any of their PPE suite can fail. So I'd like to thank Sridhar Cowley for his exceptional guidance on this project. And I've got some feeder questions just to get the conversation started about the on-body power module. If everyone can see these, let me know if you're interested in the answers. Chris, should we open up for questions?
Yes, thank you, Drew. Very good. Yeah, if any in the audience have questions, please post them in the Q&A box. If you're not able to access that box, you can also email them to the email address that Dusty has posted in the question box. Looks like we have one coming in. All right, so first question is, does this address powering radios with adapters for the various brands and battery case designs, or does it only address USB devices?
That's a great question. So we recognized early on in the project that if we're not addressing land mobile radios, we really haven't ticked the very first box. So ideally, you would use a battery eliminator cable, just completely get rid of the radio's battery and just leave it mounted to your vest. If that's not a situation that you want, then you can use a cable that connects in between the radio and the battery. So you still have a battery, and then we're basically trickle charging the whole time. But yes, we're focused on Motorola and Harris radios right now. We have solutions for both of those. And so while they're not in the traditional scope of USB power delivery, we've got custom cables for those, and we set the voltage request from the cable itself back to the on-body power module saying we want 8 volts or we want 12.6 volts for this land mobile radio. So yes, we are working on LMRs.
All right, fantastic. All right, any other questions?
Chris, if you don't mind, we had one, and I kind of wanted to help rephrase it for better context for Drew. And so there was questions related to the first responders that may be able to leverage this technology or capability that you're developing. I know you talked about that a little bit, but I thought maybe folks may have missed that part. Maybe they joined late. And the other, I guess, aspect of this is you talked about testing. I don't know if the question is related to if you're looking for other opportunities for testing.
We are always looking for opportunities to show this to first responders. The project got a little bit of a slow start due to COVID, but now we're at the point where we need to get out there and get feedback from first responders. So like I said, we are in the Golden, Colorado area. We're not shipping these units to anyone, but if we can fly out and meet you, or you're in Colorado, we're more than happy to show it off. And then, like I said before, because the system is the on-body power module, 2 battery packs, and some cabling to wired device pouches, we see, at least right now, that the applications for this are ones where you can use a utility vest. Does that answer the question for you, Dusty?
I believe that will help. Yes, thank you.
All right, if there's no other questions, I think we'll move on to our, so you might have one coming in, Dusty, is that true? All right. Last question then for you, Drew, is Sridhar Cowdley, the topic manager for this contract, is asking if you could talk about potential for using commercial batteries at a local store in a pinch. You got to join a meeting. Okay. Yeah. Will you be able to use commercial batteries from a local store in a pinch?
The answer is yes. At this point, we're talking about AA batteries. So AA batteries are very comfortable when they're giving milliamps. And during transmit on land mobile radios, that can be significantly higher than just a few milliamps. So what we have come up with is a 12 AA battery pack that you can self-fill if you have to, and then keep working.
All right. Thank you very much, Drew.